Hello. Alright. Again, we're going to discuss about problem solving involving the system of linear equation with three variables. Alright. By using the matrix concept, we can solve the system of linear equation with three variables by using matrix method. Alright. Matrix. So the question if you have a question, you try to look at the question. The question is about, in an annual sale, a furniture shop offer three different types of sofa set: full leather, half leather, and fabric. So there are three types of sofa. So which is full leather, half leather, and fabric. A sales promoter who worked for the furniture earned a commission for each set sold based on the types of sofa, the commission. So the table already summarized for you the commission, right? So means that okay, commission earned in 3 months. So means there is the first month, the second month, and the third month, right? So the first month, if you see the table there, they have full leather, right? Full leather. So the full leathers and half leathers and fabric. So this is by column, right? So for row, so by the row, this is the first month. They never, but you understand the question, right? First month, second month, and the third month, right? Third month. So means the first row is represent the monthly commission. So means the first row you have X, right? We just write multiply because the X, Y, Z, X represent the commission, right? So we don't know how much the commission is. So now for full leather, the commission is X, right? Why X? Because 1 times X. For the first month, they only sell 1 full leather. 1 full leather, you have X commission 1. So for the half leather, they sell the 2 half leather. So means the 2 half leather multiplied with the commission for half leather, then plus with 3 fabric. Total is 1,900. As simple as that. Okay. So you have, okay, for the second month, they have 2 full leather and Y and 4 fabric. So which given higher commission than the first month, right? Maybe because of the full leather, or maybe because of the fabric, right? We're not sure. So we need to calculate, right? We need to calculate how much commission they get when they sell full leather, half leather, or fabric. So for the third month, only sold for 1 full leather, 1 half leather, and 2 fabric leather. So total, the commission is 1,300. You must remember, X represent the price, the commission, right? So if you have 2 full leather, you have to multiply 2 lah, okay? Because one full leather sofa, X commission. So 2, you have 2X. So then you have get the system of linear equation with 3 variables. So in this case, of course, they want you to using the matrix, your knowledge for matrix. Okay, then you have obtained a system of linear equation, or you have obtained the system of linear equation. So now, you better double check your linear equation before you continue, right? So, okay, should be correct. So later, of course, if you want to use the knowledge for matrix, they will ask you to express the system of linear equation in the matrix equation, in the matrix form. So you have 1, 2, 3, 1, 2, 3, 2, 1, 4, right? 2, 1, 4, 1, 1, 2. So write in matrix form. So X, Y, Z equals to 1900, 2200, and 1300. Okay, this is your matrix equation. Alright, so now we have to depend on the question. Alright, either you want to use adjoint matrix, the inverse matrix method, or this question they asking, highlight the keywords there. They asking you to using the Gauss-Jordan elimination method, right? You have to solving the system by using Gauss-Jordan elimination method. Do you still remember that? If you forget this, better you refer back to the previous video. Elimination methods. Okay, this method refers to using the concept of elementary row operation, which you write the matrix in the form of A and the B, right? And at last you perform the ERO, then at last you will getting the identity, and this one will be your X. Your X means this one. This is your X. This is your B, and this is your matrix A. So, okay, the meaning here is you perform elementary row operation until you get the reduced row echelon form. Means this is must be an identity. Alright, for Gauss-Jordan elimination method, you must reach the reduced row echelon form. So now, let's start the process here. So of course you need to rewrite this. Okay, I need the space, so I'm going to erase all this. Alright, so this is a long process, right? So understood, you need a space for this. Okay, you have 1, 2, 3, 2, 1, 4, 1, 1, 2. You write in the augmented matrix form. Augmented matrix. So where there is a line here, and your V you were putting here 1900, 2200, and 1300 in this form before you perform the ERO, right? Okay, now let's start the process here. So 1, 2, 3, 2, 1, 4, 1, 1, 2, 1900, 2000, 2200, 1300. So, okay, so you remember the process of elementary row operation. You have to make sure the first to be 0, right? So you want to make something to be 0. The ERO got 3 types, right? You have alright, let's move on with you interchanging, right? You can do interchanging between the row. So secondly, you can modify the row by multiply with a constant where the constant shouldn't be 0. Or the third one, you can modify the row by taking the row add to the constant, or multiple of another row, right? Of another row, and the k also shouldn't be 0. So I have tell you the best here is you're going to restrict this operation only for when you want to make the entry become 0, right? These two, the operation is to make something, an entry become 1. Yeah. So this is the method that I suggest to you, but there are different kind of method you can apply the ERO without any rule. So this is for safe, right? So okay, let's move on with the first operation here. The first operation here is you must make sure this to be 1, right? And then you have already reached 1 for this, right? It's already 1 here. So you have skipped the first step. The first step have done to making this 2 become 0 now. Making this 2 become 0. So means that you have to make this 2 value here become 0. So you want to make something become 0, there's only one operation. You refer to another row. Okay, what does it mean? So this is the second row, the third row, right? So means this is something that you want to modify. Means that the second row and the third row you need to modify. So how do you modify? You take that row, refer to the row that you are not modifying here. The first row, right? The first row, the row 1, the row 1. Then the value here is depend on the value here. You change the sign. If positive 2, it will be negative 2, and 1, it will become negative 1. So negative. Then you follow this formula and carry out the operation. So you have 1, 2, 3, 1900. This one I copy back because row 1 is not involved in the operation here. So now row 2 minus 2 row 1. For this entry here, you will refer to row 2 and row 1. Row 2 and row 1. Now is row 1, row 2, row 3. So row 2 and row 1. So 2 minus 2 times it from row 1 is 1. So you have 0. You still remember that? So now I'm telling you. So you perform. If you calculate, you will get -3 for this, -2 for this, and -1600 for this. Just follow this formula. Okay, I show you another time. You see, -3, right? So this is the 1 and 2, right? For this value here, right? So it's between 1 and 2. So you put 1. 1 minus 2 times 2. 1 minus 2 times 1 minus 4, you get -3. And for this, you take the 4 and 3. 4 and 3, right? 4 minus 6, -2. And this one, of course, you take the row 2 and row 1, right? For this value here. So you take the row 2, you insert 2200 minus with 2 times 1900, you get -1600. Okay, the same thing happened for the third row. You follow the formula. It's between row 3 and row 1, right? It's between row 3 and row 1. You just minus. For this one, you take 1 minus 1, you have 0. For this, you take 1 minus 2, you have -1. 2 minus 3, you have -1, right? So, and the last one, you have 1300 minus this one, you have -600. Right, -600. So, okay, double check every value here so that you are getting correct before you proceed. So now you have making this 2 become 0. The next job here is to make this become 1, right? Make this become 1. So we want to make something become 1. I repeat again, you might make something become 1. Either you interchange or you multiply by a constant. This case, you have two choices. You can multiply everything with -1/3, but this is not nice. You can do it, but not nice, because you start the operation early with fraction. You will get 1 here, of course, but you get 2/3 here, right? If you like fraction, you can continue with this operation. So I will strongly suggest that you're using the interchange. The interchange. Interchange first, doesn't matter. So let's see. We interchange. I think the -1 is helpful here, because you interchange, the 0 will go up, right? Here remains 0, and this the -1. Never mind, we change first. The row 2 interchanging with row 3, right? Interchanging. So, okay, we decide later. Will it helpful? We decide later. 0, -1, -1, -600. And this will be 0, -3, -2, -1600. Yeah, but this is not 1 yet, right? It's -1, right? So now you have used interchanging row. So the next one, to make this become 1, okay, you can use you have used interchange, you can multiply with a constant. What is the constant? Any constant, but cannot be 0. So how? You multiply with -1, right? You multiply with -1. So you take the second row now. The second row now, you multiply with negative of the row 2. You are modifying. So, okay. So the one that remain is 1, 2, 3, 1900, and 0, -3, -2, -1600. Okay. Now this one becomes 0, 1, 1, 600. Because you have multiplied the negative for every entry and this row. So you have positive everything here. So now you have safe, right? Where this is already 1, right? So you have complete the step 1, step 2, step 3. Now go for the step 4. Make this 2 become 0, right? So when you want to make something become 0, this is the operation. This is the operation. So how? So let's continue. Okay. Alright. So you will see that this one you want to modify which row? You want to make this 2 become 0. This one come from what? Come from row 1. Right? Come from row 1. And this come from row 3. Right? So row 1 and row 3. These 2 rows refer to the second row. Already 1 here, right? The second row. So if 2 minus 2. If -3, you plus 3. As simple as that. Okay, if you can see the flow, ERO for you is very easy. So row 1, row 3 modify, but row 2 is not modified. So copy back 0, 1, 6, 6, 600 here, right? So I do for you. Another time I show how you want to apply this. Row 1, this formula is between row 1, row 2 and row 3 now, right? So it's refer row 1 and row 2. Row 1 and row 2, right? Every element here. So for this, for the row 1 and row 2, 1 and 0, definitely will be 1, right? If you put 2 and 1, right? 2 and 1 for this, 2 and 1, you have 0 here, right? 3 and 1, 3 and 1, you have 1, right? You have 1. So now let's move on with this. So this one is minus 1900. You put in minus with 2 times 600. From my value here, I will getting 700. You can double check with me. Double check with your solution with my solution. So, and now if done for the first row, go for the third row. So the third row will be, you take row 3 plus 3 row 2. The row 3 and the row 2. Definitely will 0. Negative 3 plus with 3 times 1. Definitely 0, right? Negative 2 and 1, row 3 and row 2. So, negative 2 plus 3, you have 1 here, right? You have 1 here. And this one, you negative 1600 plus with 3 times 600, 1800. So you have 200. But don't stop here, because this is not row reduced echelon form. This is not an identity yet. So the last one, the next step after you're making this 2 become 0, this one have to be 1. And safely, this is already 1, right? So you have to skip, you have skipped this step because it's already 1, right? So now at the end, you're going to make this 2 become 0 so that it become identity. Okay, so let's draw here. This 2 becomes 0. You want to make something become 0, you have to using this operation. So you have to refer to the row 3. This one is from row 1. And this is from row 2. And you have row 1 and row 2, right? Row 1 and row 2. 1 and 1. And refer to the row 3. Row 3 and minus, right? Post 1, negative 1. 1, negative 1. Okay? So just minus. Then you will get what you want. So definitely if you have row 1 minus row 3, row 1, this is row 1, this is row 2, this is your row 3. Row 1 minus row 3, you have 1, 0, 1 minus 1, 0, 0. 700 minus 200, 400, right? Sorry, 500, 500. And now row 3 is not changing, it's not modified. So now it's row 2 minus row 3, 0, 0, you have 0, 1 minus 0, 1, 1 minus 1, yes, finally you have reached identity for this, right? Okay, 500, and you take 600 minus 200, right? So you have 400. So you have 500, 400 and 200. Okay, now this is already a reduced row echelon form, right? You have performed the Gauss-Jordan elimination method completely, alright? So after you're getting this will be your x, right? Your x will be 500, 400 and 200, which is actually your x, y and z. So therefore your value of x is 500, your y is 400 and your z is 200, right? So I have told you before, this is a question that involving problem solving, right? That is a situation here. So that is a story here. So you have to answer back the question based on what the required by the question. So therefore, the commission earned on the sales of a set of sofa of each type means that the commission for selling the full ladder, right? This is for full ladder is 500, RM 500, and the commission for selling half ladder is 400, and the commission for selling fabric is only 200, right? So as you know that which one is more commission higher, right? So after you calculate, you plan to focus on full ladder, right? So you can get more commission, right? So this is the you need to calculate so that you know the commission that you get. So that's all for this question. Hope you understand.